All right, so if you're really doing research for any purpose, if you're working for an agency, if you're working as a researcher, if you're, I don't know, whatever you might be doing, to run a t-test, you will not be doing it by hand. Instead, you'll be doing it in some kind of statistical software. And there are a lot of software packages. As I've said before in this class, I'm not making you guys focus too hard on learning any particular one. Chances are whatever job you're in is going to dictate which software package you end up using if you end up in a job where you do this. So the most important thing is to be able to interpret what's coming out of it. So I'm just going to give you an example of one kind of output from Stata, which is a software package that's used pretty commonly in the social sciences, and show you how to interpret it and what things correspond to different parts of the t-test. And I'm going to come back to our class data for the first time in a while now and look at the question of whether male and female CJ students have the same mean number of tattoos. Sticking with the gender comparison, because that's an easy one to do when you're comparing, two groups. And I didn't ask that many questions of you guys where there's like two distinct groups. So the question is going to be, do male and female CJ students have the same number of tattoos? And we're going to treat the sample of this class like a sample of CJ students overall. It's not really a random sample. You guys weren't randomly assigned to be in my class. You signed up for it for various reasons. You're at different points in your academic careers than other CJ students. But for the purposes of this, we're going to ignore all of that. We're going to pretend that you guys are a random sample of CJ students, and we're going to try to use the class data to learn something about CJ students overall at Rutgers. So our null hypotheses for this hypothesis test are going to be that among criminal justice students, the mean number of tattoos for men is the same as the mean number of tattoos for women. The alternative hypothesis would be that men and women have different numbers of tattoos in the criminal justice program. And so we'll be looking to see whether the sample, so our class survey, gives us evidence that there's a difference in the number of tattoos that men and women have. So the output from Stata looks like this, where it says t-test tattoos by gender. That's the Stata commands that gives you a t-test for the variable tattoos, splitting it up by these two different groups that are for male and female students in the class. The way that it's coded in the program, Group 1 is men, Group 2 is women. If you remember way back, coding is just assigning numerical values to different variable attributes. So here in the survey, those of you who identified as male in the survey got a 1 in your column, and then those of you who identified as female in the survey got a 2 in your column. So Group 1 is men, Group 2 is women. Now, you should see some other things that look familiar in all this output. The top of it's covered now by the other box, but these are the sample sizes for each group. So among people who answered this question, 25 identified as men, 28 identified as women. This next column here shows you the sample means for each group. So among men in the class, we had a mean of only 0.84 tattoos, so less than 1 tattoo on average. For the women in this class, we had a mean of 2.32, followed by some other stuff. So we had an average of about 2.3 tattoos for women in the class. So that's seems like a notable difference. Another thing to pay attention to here is this value, which shows you the difference in means. So this is literally just if you subtract 0.84 minus 2.32 blah blah blah, it'll give you this value, which is negative 1.48. So the interpretation is that in our sample, so in this class, there is a difference in sample means of negative 1.48 between men with tattoos and women with tattoos. Over here we have the t-statistic that corresponds to that difference in means. So where in our paper examples, we would be using the t-statistic formula, we'd be plugging in the difference in means and the standard error. The program has done that for you. So it says that we have a t-statistic of negative 2.21 for this difference in means that we see. The program also gives you a p-value. And there's a couple of different p-values along the bottom of this slide here. The ones on the left and right are for when you're doing tests where you specify which group you think is going to have a bigger mean or a smaller mean. Since we're not doing that, we're just focusing on the hypothesis that they're different. You can ignore those completely and just focus on the one in the middle, because that's the p-value that you need. So here we have a p-value of 0.0313. The interpretation for this p-value is the same as the interpretation for the p-value that we've seen before. So if the null hypothesis were true, and if men and women in the CJ program had the same number of tattoos in that overall population, there's only a 3.1% chance that we would see a difference as big or bigger than the one we see in our class. So again, if you guys all had the same number of tattoos, there's only a 3.1% chance that we would see women having, 1.48 more tattoos than men on average in this class. If we were using an alpha level of 0.05, which is your standard alpha level, we would reject the null hypothesis then, because this is in the least likely 5% of differences in sample means that you'd get if in the population there really was no difference. Yeah, and then so that would be it. So what you can see on this slide here is that you've got all the components that we've seen in the paper examples in different places on this output. Some of it you can probably also guess what it means, but you don't really need to pay too much attention to it for anything we're going to be doing. And then the interpretation here would be the same as the interpretation for this p-value and t-statistic and all that we saw. The nice thing about this is that instead of going through it by hand and drawing pictures and all that other stuff, what you type into the program would be t-test tattoos by gender, and then all this would come out and you would have your answer. So this is how it's typically done when t-tests are run in the real world. And one more note before I sign off here and let you get on with your day. T-tests are used really, really commonly in research. Anytime you have say an experiment where you're comparing one group against another group, a t-test is going to give you the answer. So if you're reading research studies for your classes, you might see t-tests in there, and they're going to be based on something exactly like this, and exactly like what we've been doing this week. All right, so that's all I have for you guys today. Problem set is due at the end of the week as usual, and if you have any questions, let me know. Come to my optional Q&A session / office hours. And otherwise, have a great week.